So let's change each interval, each inequality into an interval notation. So please give me the interval notation that represents x less than or equal to 2.
So negative
Yes?
negative to 2.
Exactly, with a bracket. Very good.
Yes.
Perfect. Awesome. So this is negative infinity to 2. Can anyone give us the interval notation for the other one? Awesome. With a parenthesis because it's not. Perfect. Now here, I have more chances maybe to find a domain. And also, I'm preparing it for the chart. So, can anyone identify the domain for us? Exactly. Nothing is missing. From negative infinity to 2, 2, and from 2 to infinity. What value of x must be in the chart even if we don't want it in there? And why is that? Because something very important happens at 2. The function changes from this function to this function. Yes, exactly. 0 must be in the chart 2. Under 2, I will have a bracket facing this way because this is what it means. And a parenthesis touching it facing this way because the function is defined at 2. Sorry about that. Okay, so now in this interval, what do I use? I know it's an overkill, but these may not be presented in the correct order. So I'd rather put them here also. Indeed, x squared minus 1. What function do I use for 2 to infinity? Negative x plus 2 indeed. Good. How do I graph this, and what type of function is it, and what type of function is that? What type of function is this? Perfect. What type of function is this? Awesome. Linear. Good. How do I graph this? If we use transformations, can anyone tell me what to do? How do I graph x squared? A parabola. And then what do I do with it? If I change x, yes. If I change y, no. What am I changing? Down 1, because I'm not changing x. Very good. So give me some points so I can graph this. So if it's here at x squared at the origin and it's down 1, then I know where it's going to cross. Perfect. Yes, and 1. Awesome. So let's plug in negative 1. What do we get? Awesome. Let's plug in 0. What do we get? Awesome. Plug in 1. Good. Plug in 2. And I have to put the number right here inside the bracket. Good. Plug in 2. Plug in 3. Negative 1. Good. That's all we need. From left to right, can anyone dictate the first ordered pair?
Negative 1, 0.
Good. Second ordered pair.
0, negative 1.
Next ordered pair.
1, 0.
Next one.
2, 3.
Very good. What type of point is that?
That would be a closed point.
Indeed, because of the bracket. Awesome. So here it is. Now on the other side. First point.
2, 0.
Good. What type of point is this?
Open.
Indeed, it cannot be closed. If it's closed here, it cannot be closed here. It will not be a function. And then
3, negative 1.
good. Now I'm going to also ask about the range of this function. What is the range of this function?
The negative infinity to infinity.
Yes, indeed. Good. Perfect. Anything else? Yes. Alexis? No, you had a question.
Oh,
What was it?
the function composition.
Right. Here's an example with function composition. Any questions on this?
That was piecewise.
Piecewise. That was piecewise defined function. Yes. And then I would like to look at a difference quotient unless you have something else. So here it is. Let's say f of x equals 1 divided by the square of x plus 1. I want you to find two functions, inner and outer, to decompose this. I want to decompose it into an inner and outer.
What kind of problem is this again?
Function composition. So it's this one. Let's call the inner g of x and the outer h of x. So we want to decompose the function.
So it would be
Let's start. We have to start with the inner.
x plus 1.
Good. Awesome. X plus 1 is the inner. Once I get a number, this is just one number now, what function do I apply to this number to get the whole thing? So,
H of x. Where can you put
so I got a number.
1 over square root of x?
That's it. That's what I have to plug in. That's an example with function composition. Difference quotient. So please give me a function.
That's all you can do for that?
Say it again.
That's all you can do for that one?
Decompose it in an inner and outer.
Break it out.
So give me a quadratic function. So we did piecewise, we did the difference quotient, we did an example here, we did not do the circle, okay? Anyone? A quadratic function? Okay, negative 3x squared plus 2x plus 7. We're asked to find the difference quotient. You don't have to memorize the definition of the difference quotient. It will be given to you. And here it is. F of x plus h minus f of x over h. Where is my starting point? What do I have to do first?
You substitute in the f of x into the formula?
F of x is this piece.
Yeah, so you would put that as the negative 3x.
Yes,
squared
I
minus-
will. Yes, when I will distribute negative 1. Okay. But before that, I completely agree. Before that, I have to work on something else. What am I talking about?
F plus h.
F of x plus h. Yes. How do I get that? How do I get f of x plus h? Anyone? How do I get f of x plus h? What do I have to do in order to get f of x plus h? Yes, dictate. Give it a shot.
Oh, 3 into negative 3 into x
Negative 3x plus h squared.
Very good.
Um, plus 3 No.
It's 2.
2x.
Do we understand this step? This is a crucial step. Do we understand it? Yes? Perfect. I have to continue. By the order of operations, I have to copy -3. What do I do next? And let me write a note for you. I'm ready.
X plus 2xc
Awesome.
plus h squared.
Yes. Plus 2x plus 2h plus 7. Okay, and the final form, final simplified form, I cannot do anything beyond this, to this piece is what?
Distribute.
Yes, -3x squared minus 6xh minus 3h squared plus 2x plus 2h plus 7. Yes. So now I have this, and I have this. I will put all these 3 pieces together and simplify the difference quotient. Ready? So, difference quotient. Instead of this, I copy this whole thing. -3x squared minus 6xh minus 3h squared plus 2x plus 2h plus 7. I only copied this. Now, what do I write?
Over 8.
Say it again.
Over 8.
I'm here now.
Minus,
Oh, okay.
and then the original equation.
So just dictate and I'll write it.
Plus negative
Plus 3x squared
plus 2x
Minus 2x minus 7.
divided by h. Okay. Now, before we consider simplifying or doing something else now, remember there are 2 things that have to happen here. Mandatory for any difference quotient. What is the first one? Yes, I will get rid of that h. That's the second one. The h in the denominator, if that's what you wanted to say. Yes, but what has to happen? All terms without h must go away. And what is the second thing that has to happen? Eventually, yes, awesome. And eventually this h in the denominator must go away. The simplified form of the difference quotient will still have h in it, but not that one in the denominator. Good. So let's make sure that all terms without h go away. The -3x squared with the positive 3x squared, the positive 2x with the negative 2x, and the positive 7 with -7. Exactly what we expected. However, terms that have h may go away too, but it's not the case here. But that's okay if that happens. But definitely all terms without h must go away. Okay, how many terms are left? Good. What do they have in common? And they must have in common. Yes. Because that's how the h from the top with an h from the bottom go away. So what is left here in parentheses? Yes?
3h
Minus 3h.
plus 2.
That's it, and that's the final answer. So please practice the difference quotient. What else do you have in mind? What about the circle?
Go to a circle, we didn't do that.
Okay, very good. So there are 3 types of problems with a circle. You are given the center and the radius, you find the equation. You are given the equation, you find the center and the radius. And the third type is you are given a mumbo jumbo and you're asked, is this equation the equation of a circle? Which of these 3 types you want to look at? The mumbo jumbo? Okay. Okay, so let me pick a problem then from your text, because it will take me a minute to make one up. Okay, so that is at the end of chapter 2. So I'm going to pick Yes, found it. Let's say 53 on page 332. So we have x squared plus y squared plus 6x plus 2y plus 6 equals 0. Okay. So can anyone dictate the equation of the circle? If this is a circle, what will it look like?
Plus x minus h.
Very good. Wonderful.
Y minus k squared.
Equals the radius squared. Awesome. So if I do whatever magic to this equation, to that equation in blue, and I get this one in green, then I'll say, yes, it's a circle. And I will identify the center and the radius. So what does this mean? Look at this and look at this and say, oh, I know you must do blah, blah, blah. What is that blah, blah, blah? What do I have to do to this? And we just did it a few minutes ago. How is it called? It's called completing the square, because there are two squares, right? So I will take this and I will take this and I'll say I need what to both sides? Exactly. Good. So now this term and this term and this term are here. Put them in there and tell me what to write. Exactly. X plus 3 indeed. First term squared plus 2 times the first times the second plus the second term squared. Awesome. Plus, I will have to do now the same thing to these two. And please tell me, what do I have to add? Thank you. I'm sorry. Okay, so now these three are here. I didn't mean to put them in there. Sorry. Okay, so what do we have? What is this squared to give us this and this and this? Yes. Yes. The middle coefficient divided by 2 and square. Good. So then, yes, indeed, y plus 1. Very good. And now, what is not accounted for is this, and is this. But you have to move 6. Yes. So the answer is 4. Very good. Very good. So, is this a circle?
Yes.
Yes, because I was able to complete the square with x. I was able to complete the square with y. This is positive, and this is a positive number. So now what is the center and what is the radius?
The center is
Negative 3, comma, and the radius is 2. Awesome. And now I want to graph this, because I may be asked to graph it. So when I'm asked to graph a circle, where do I start? What do I have to do first?
the radius.
The center. Very good. Negative 3, negative 1. 1, 2, 3, 1. Then I will create 4 points. East, west, north, south. 2 units away. 1, 2. 1, 2. 1, 2. 1, 2. And this is the circle. Center the negative 3, comma, negative 1 with a radius of 2. Any questions? Any questions? So this was the circle. Do we need another example with Gauss? Yes, yes, please. My pleasure. Do we need another example with Gauss-Jordan?
Yes.
Yes? Okay. Any problem? Or you want to do the test problem, or do you want me to choose one?
Can we do the test one?
Yes, of course. Okay, remember the sequence of steps. 1, and then the corresponding zeros. 1, and then the corresponding zeros. 1, and then the corresponding zeros. You cannot deviate from this. This is the only way. Yes?
I just have a question. On my math lab, we don't have to get the zeros in the left.
They are using Gaussian elimination. If you
So-
prefer that method,
Okay.
I'm okay with you replacing the Gauss-Jordan with Gaussian elimination with back substitution. It's more difficult.
It's more difficult.
But if you understood it, if you are comfortable with it, I'm comfortable with it. You don't have to solve it using Gauss-Jordan. Okay, good. So the problem from the test. Can you dictate? Can anyone dictate it?
X plus y plus z equals 0. X minus y minus z equals -4. X minus y plus z equals 2.
Good. Okay, so I'm asked to use Gauss-Jordan. My first thought is all terms with x, all terms with y, all terms with z, the equal symbol, and the free terms have to be one under the other. They are. Otherwise, I will have to rearrange the terms, add, subtract, move terms, whatever. There is no need here. I can start the algorithm by writing the augmented matrix. A vertical bar, and lowercase b. So this is the A, and this is the lowercase b. 1, 1, 1, 1, negative 1, negative 1, 1, negative 1, 1, 0, negative 4, 2. Is this okay?
Mhm.
Perfect. One more time. Here is the order of operations. This is the first step. This is the second step. This is the third step. This is the fourth step. This is the fifth step, and this is the sixth step. This is the seventh. This is the eighth, and this is the ninth. Or 8 and 9, it doesn't matter. Okay? 5 or 6, doesn't matter. It can be 6 and 5. But this and this and this must be first in the sequence. Because only the ones, this one allows me to get the zeros here. This one allows me to get the zeros here, and this one allows me to get the zeros here. Okay. So this has to be a 1. It's already done. I will be using which row now to obtain the corresponding zeros in that column? Which row will I use? Row 1. So I will write myself a note on the side. Row 1 multiplied by something plus row 2. Row 1 multiplied by something plus row 3. So what do I multiply row 1 by to get the 0 here? What do I multiply row 1 by to get a 0 here? Both of them -1. Do you all agree? I know you understand the procedure, but if you don't take the time to practice with 6, 7, 10 problems, when the final exam comes, you're going to have difficulties with it. Okay. Because it's only practice. It's not a big deal. Okay. So, ready? 1 times -1 plus, oh, I'm sorry, I have to copy the row I'm using. This row will not change because I'm using it. 1 times -1 plus 1. 1 times -1 minus 1. 1 times -1 minus 1. 0 times -1 minus 4. Okay, let's do this one more time. If you have any questions, let me know. 1 times -1 plus 1 is 0. 1 times -1 is -1. Minus 1 is -2. 1 times negative 1 is negative 1, minus 1 is negative 2, and 0 times negative 1 minus 4 is negative 4. Is that okay? Next one. 1 times negative 1 plus 1. 1 times negative 1 minus 1. 1 times negative 1 plus 1. 0 times negative 1 plus 2. 2. This is done. If during the next steps I destroy this, I'm not on the right track. This is now carved in stone. Good. Next step. I'm here. I know I want a 1 in this spot. How do I get a 1 in this spot? Divide row 2 by? Very good. Is that okay? Good. Which row I have? Not yet, sorry. I'm ahead of myself. So 0, 1, 1, 2. 0, negative 2, 0, 2. Which row? I have 1. So now I need the 0 corresponding to the zeros in the second row, column. Good. Which row will I be using now to get the 0 here? And I will be using now to get the 0 here.
I have a question.
Yes.
When I did it online, so I did that step before, but I switched 2 and 3
You
and
can.
then divided by 5.
You'll get the same thing.
Those are 2.
Good. So we are using row 2, multiplying it by something to add to row 1. And we are using also row 2 and multiplying by something to and add it to row 3. Say it again. Negative 1 for the first one, and for the second one? Very good. Awesome. Which row do I copy now because I'm using it and it's the only one that will not change? Row 2 indeed. And also remember, this column cannot change. 1, 1, 2. Ready? 1 times negative 1 plus 1. 1 times negative 1 plus 1. 2 times negative 1 plus 0. Very good. Awesome. 1 times 2 minus 2. 1 times 2 plus 0. 2 times 2 plus 2. Done. Those two are carved in stone. No one can change those. Okay. Final step. I shouldn't say final. I want a 1 in here. Cannot use 2. I need a 1. Divide row 3 by 2. 1, 0, 0, 1, 0, 0, and I divide by 2 and I get 1 and 3. 1, 2, 0, negative 2. I copied the rest. So I obtained the 1. Now I want the 0. This is already done. I don't have to do anything there. Which row will I be using? I have to use row 3. I have to multiply it by something and add it to row 2. What will I multiply it by?
Negative 1.
Negative 1. Which row do I copy now for sure because I'm using it and it cannot change? Row 3. 0, 0, 1, and 3. And of course the first column and the second column. And of course the 0 and the negative 2, unless because it's already done over there, but I only need to do this. 1 times negative 1 plus 1. 3 times negative 1 plus 2. Very good. I'm not sure, but I expect the solution to be. Why I'm not sure is because I still have to check. It's so easy to make a mistake with this. So I expect the solution to be,
Negative 2, negative 1, and 3.
that's it. Any questions? Any questions? This is how I would prepare for this test, for this final. I would redo all 3 tests with solutions till I understand each and every problem. And then I'll say, okay, let me check here. What are the core problems in test 1? Okay, equations, word problems, inequalities, domain. Then I will look at test 2. What are the core problems here? And I will find more problems. Yes?
Do we need to memorize like every formula?
Give me an example of a formula.
I don't know, like the A plus, there was one like A plus B that I couldn't remember in the last one. Do you know how many questions on the final?
Exactly 6 plus 6 plus 6. However, equations will have part A and B, maybe C. Inequalities may have part A and part B. One exponential equation, one log equation, one Gauss-Jordan elimination, one nonlinear inequality. Sequences may have 2 or 3 problems because they are so, I don't want to say simple, but not involved. So here I may have part A, part B with different questions, a recursive formula, an nth term formula to find some terms. The difference quotient, one problem. The piecewise defined function, one problem. A domain of functions and reading from a graph. If you look back to chapter 1, you will see what I'm referring to. Finding a point on the graph, finding the domain, finding the range, increasing, decreasing, that type of problem. Word problems, again, just one word problem pertaining to what we did in that chapter and what you saw on the test. Nonlinear inequality, just one, because it's either polynomial or rational. You have to use the chart or another method, so it takes a while. Yes?
Is there gonna be compound interest in
It's the word problems in test 3.
it?
Will we have a chance for extra credit?
Yes, of course. Yes, I will have a couple even to choose from for extra credit, of course. I will also do one other thing. So if I see that someone had, let's say, a low test grade on test 1, but completed all this with a very good portion of that test, I may even replace that test grade with this.
Oh.
I'm going to try to help as much as possible. So I'll do even that. Trust me, I do care. I really do. I hope I showed that I care. So I really do care about my students and their progress in my class. So my question now